Hello everyone, welcome to this session on robot control and artificial intelligence. So we are now starting, and like if any of your friends are joining, then you can share the joining link with them, and they can join it. Uh, so I think it's already 4:05, so I can start. So So today's session will be mostly on like what kind of algorithms will be we can use for controlling robots, and like how is it that we can actually train our own robotic arm like for several applications. Basically, like I will be talking about the applications and like like what all algorithms we have in reinforcement learning. So this session will be purely introductory, and if I get many like responses on the slides, and if I get to know that like so you people are liking it and you need more information, so we can schedule a follow-up lecture sometime the weekend or maybe next week. So like let me go ahead. And so basically, like before going with the content, let me tell you about myself. Like I'm primarily working in computer vision and reinforcement learning. And like if you want to know about my work profile, you can visit this link. I have listed my projects and all of the rewards publications that I have received from my work. Like so all of the information is listed there. Uh, like so in my PhD, I got a chance to have 8 top tier publications, like in various well-known journals and conferences. And for my research, I have received several travel grant awards, including from Microsoft and Google as well. And I have qualified national eligibility test from Government of India with a significantly high percentile. And I have received a few other prizes like for my research. And I have experience of working on industrial robots at Sony AI from Tokyo. And along with that, we also have a large AI community in India. If you want to join that community, you can like go to this link. There are like links for like all social media that we have, and you can join any of the platform, and like you can receive the wonderful content that we are sharing regularly in that group. So along with the information on AI, we are also sharing internship and job opportunities. So you can refer or you can join this community also for receiving those notifications. Like apart from it, like we also have a startup, AI-Shala Technologies Private Limited, where we are working on several exciting projects like virtual trial room, fashion analysis, fitness analytics, vision for blind, and we have several like reinforcement learning based projects as well. So in this session, we will be talking mostly about the 4 things. One, like initially in the few slides, I will tell you about the job market for like AI, like why you should have these skills now itself, so that in the future you can be the boss of this market, right? Because these things have started few years back, and you can see that like so like every industry has moved to AI based things, even for trimmers and like your what we say hair straighteners also you are using AI, right? So the companies are using AI applications. Then the second part of the slide of this presentation, I will be talking about applications of robotic arms, and then I will give you a small introduction about reinforcement learning, and then I will tell you how is it that you can learn about these algorithms and like train your own robotic arm in simulation. And like so basically, like this is a very introductory session of 30 minutes, and if I get good response from your side, and if you are asking many queries, like we will schedule a follow-up lecture maybe in the weekend or next week, as per like whatever you guys will have the recommendation. Okay, so as you guys know that like AI is revolutionizing our world, and we have seen a tremendous improvement and like exposure to AI in various fields. Like it's starting from autonomous vehicles to robotic surgery. AI is everywhere nowadays in our personal life, in our professional life. Like if you are walking on the road, like so you are seeing many things which are from AI. And like so basically, like so what I want to say is like AI has entered in our life, in our day-to-day life, like whatever we are doing in the personal thing, professional thing, right? So for example, you are holding a mobile device, right? The many of the applications that you are using AI, like in terms of text, in terms of vision or whatever, right? So the sensors of the mobile are actually getting collected, are collecting your data, and then the data is processed by the different applications, and these applications are using AI for your, maybe for your health, maybe for your like scheduling calendar like meetings, or maybe for like reading your voice pattern and unlocking the phone, facial recognition, other things. So there are various things that the different mobile applications are using AI. So I am showing two major applications here. One is autonomous vehicle, and the second is robotic arm, where a robotic arm is actually picking objects from a plate, and it should actually place it somewhere else. But we are only showing the picking part here, and so this is very commonly used. Earlier these were only mechanical systems, and people were using them manually. But nowadays there are like automated algorithms where you can pick the objects and place it somewhere else. Like, so Amazon is using these heavily in their warehouses, so that they can handle the objects very delicately. Autonomous vehicle, you must have seen various like news information where Tesla or any other tech giant like actually working on their autonomous vehicle, and they are testing it in the real world with the actual users on the highways as well. Right, so autonomous trucks are highly common in US, like, so they are actually moving at a very fast pace, and now they are also trying to like make the mobility autonomous as well. So I will be talking about these lines, why you should be like you should have these skills, and like what is it that you can actually do to actually like start like career, or like whatever. Like, so how is it that you can start learning algorithms, and how is it that you can actually train a robotic arm, or maybe like how is it that you can actually come up with some algorithms for autonomous vehicles. So basically, before going with anything, I will actually talk about like AI skills and job market, right? So basically, if you are a software engineer, a normal software engineer, I'm talking about the average salary. Basically, like, this is, if you have a few years experience, this is a pretty high. But like, so I'm just talking about a fresher, and only the average salary, right? So basically, on average, like, so this is a survey from PayScale, like a few years old survey. But like what they actually came up with is that like in India, average software engineer actually earns 6.39 lakh per year. And if you are a data scientist, it's actually 1 million. That means 10 lakh a year. And for the lead data scientist, it is actually 20 million. And so this is a few years old data, but the actual numbers have actually gone very high nowadays. And if I talk about AI engineer, right, so it is 15.6 lakh a year. If you are on a scientific role, and like if you are working on top niche technology like reinforcement learning or robotics, so it is actually way high. Like, it is actually like 6 to 7 times more than that. So that means, if I'm talking about, you are a fresher with a PhD degree, and like, the skills like reinforcement learning or robotics, so you can actually make 10 millions a year, right? So this is what companies are actually offering to the freshers. So, like, why this is actually happening is because of the demand and less availability of the skills. Like, if you see this trend, this is a survey from like Intelli part. So basically, like, what they have actually shown is the number of job posting for machine learning related like jobs. So basically, like, so these are going exponentially high, and we don't have that much trained skill force, and people are actually like seeing more demand than the availability of these skills. So if you start today, you will actually fill this demand very easily, and you will be like making a good progress after a few years. So my suggestion is to actually like start now, so that after a few years you will be like at a senior position in this field. Right? Because now many companies have actually started training programs in AI, and like, so after a few years, many people will be graduating with these skills. So let's talk about robotics. Like, I'm showing four figures here. One is this there are two robots. One is this holding tray, and one is which is actually have a scanner at the head, and like it is doing some maneuver part. So basically, it's in a supermarket where it can go to the different racks and pick different objects which you might have ordered, and they will it will place it in a tray, and it will automatically go to the cash and the packing counter, where it will be all the items will be packed and will be delivered to you, right? So in the medical lab, basically robotic arms are actually used to mix different chemicals to actually have to handle things delicately on the conveyor belt. Like it's highly common. Like, so for example, I will give you one application. For example, what this particular thing is showing is a segregation of fresh and rotten fruits and vegetables. So basically it can actually identify using computer vision which all fruits are fresh. It can pick it up, and then this will be shown, right? I will tell you about one quick application. For example, like this is a image from a restaurant in Japan, where the chefs are actually handling some eatable items, and they are placing it in different plates, right? So this is a very frequent running restaurant. It might be a cloud kitchen, but so it looks like a restaurant where people are actually handling the food item, which is highly delicate, and if they push it very hard, like it will damage in shape, and it will not be able to serve. So many companies are actually trying to replace this men based labor with the robotic arm, so that they can actually pick the food item, and it can serve it in the plate, right? So that kind of thing that they are trying to do. So basically there are various challenges here, and like many people are like many top companies, like for example Mooli Robots is one example, where they have actually released one video where two robotic arms are actually collaborating with each other, and they are cooking some stuff. So another application is like, so for example, let's say if you have a robotic hand, how is it that you can train to open a door, right? So let's just see this video. Okay, so basically this is one particular video where it was very slow, but this is how, so the main challenge with this robotic hand is that there are many joints. There are joints in the fingers, near the end of the hand, and so we don't have the elbow, but so these have 24 degree of freedom, which is very complex, and no algorithm can actually train a robotic hand to open the door. But using reinforcement learning, like I'm showing a video where a reinforcement learning based algorithm was actually opening this door, and this was trained directly from the scratch. How and we will I will show you how is it that you can train such a robotic hand, so that you can open the door and other things. So if you have these kind of skills where you know how to train a particular robotic hand, there are many big companies who are working on reinforcement learning based algorithm, machine learning based algorithms, and they can actually hire you for these skills, and it will be very beneficial for the company and you as well. If I show you another application, so this is one another application where this is a robotic arm, this is called a panda robot, where the robot is actually using a gripper to pick objects from a plate, and it will go to the it will place it somewhere else. Like, so for example, like, so here it is only picking the object, but we can train it for the task like table clearing and other important things. So I will also tell you, like, so what are the algorithms available by which you can train the robotic. So now I will go to the learning methods. I think I will not take much of your time. I will try to finish it in 10 minutes or maybe 15 minutes. I will tell you like what all algorithms are available and how is it that you can actually uh, train algorithms. One thing is like, so if you guys have any query, you can type in the chat box. After my slides are over, I will try to show you, I will try to answer your queries and will try to interact with you based on your questions. And if you ask more questions, it will be very helpful for me to actually design the future lecture where we will tell you about like more about like training these kind of algorithms. So basically, like if I show you I will tell you about the learning methods for these robotic arms. Basically, like we can divide it into two parts where we have mathematical modeling. So for example, we will teach the robotic arm to go here, there, like this kind of model is there. Like, so we can say that, okay, we will apply this much force so that it will go to the right side with this much distance with this much angle, right? So this is a model part which is very difficult because like there may be noise in the sensor, or there are other environmental factors by which this movement may not be totally accurate, but like earlier methods were highly mathematical modeling based, and these can be divided into two parts where constraint conditions and task based. So for example, constraints, like, so for example, we apply some if and else statement. If this, do that. If this, do that, right? So these kind of things were there, like, so force based or shape based closure, like, so these are the things. Task based, like, so if we have to do, like, for example, we have to pick one item from one place to another place, we will actually define the trajectory, like, okay, so just go grip this object and like move by this angle, and you will place it there, right? So these are the task based. Another is data driven, where we use machine learning extensively, and these can be divided into the wearable devices and visual perception. I will not go into this wearable thing, but visual perception means that we have a camera on the robotic arm and it will figure out by itself like what to do, right? So you will train it, and after the training it will figure out like what is it that it needs to be like it needs to do. So there are three kinds of things that I can say about it. Like, one is deep reinforcement learning based, second is imitation learning based, and third is transfer learning based. So deep reinforcement learning, like this is what I will be majorly focus on on today's slides. Imitation learning is means like, so you have a human robot which will do the task, and the robot will actually try to imitate the human, right? So we have, this is called demonstration based learning, like, so where we collect demonstrations from the human user and we will try to copy these demonstrations to the robot. Third is transfer learning. So for example, if you already have a robot trained on some other task, we'll try to transfer that knowledge to the current task at hand. So we'll discard all other things, and I will only talk about deep reinforcement learning. How is it that you can actually go with the deep reinforcement learning? So what is reinforcement learning? Reinforcement learning is a subfield of machine learning where an agent is learning from interactions with its environment, where like, so you must have like seen supervised learning based algorithm where we are learning from the data, where we have labels. So for example, xi is your label. So sorry, xi is your data. So for example, images of a place, and yi is the label. Like, so for example, like in the image that we have, what is the location of different objects, what all objects do we have, like, these kind of label we have, and we are training based on this data. So that means whatever data we have, we know what that data is. Second is unsupervised learning based algorithm, where we only had the data and we did not had any label, like, so without any label we are training it. So that means we are given with images, and the algorithm actually needs to figure out what that image is. So here the clustering based algorithms are highly like common. Third is reinforcement learning, where we are, or basically the agent is learning by interactions with the environment. It doesn't have the data, right? It collects the data by the interactions with the environment, and the data it receives, based on that all it learns, right? So this is what it is. So basically, the data that it has is like it is coming from the interaction from the environment, and that is like, so the current state, the current action that it executes, the reward that it will receive, and the next state. So this is the interaction and data that the agent is receiving. Basically we can use it for two tasks, where first is prediction and second is behavioral aspects. So basically in the first, what we do is we try to predict the next state. The second thing is basically like we will try to predict like what action the agent needs to execute so that it will have some optimal performance. Like I will tell you like what that optimal criteria will be. Basically in reinforcement and it is reward, but it can be some other criteria as well. So this figure will actually clarify most of the things. So as I said, like interaction with the environment. So that means like we have the environment. It contains everything that like is available in whatever we have, right? So for example, like for the robotic arm we have everything, like so the table, the environment, like the force sensor, like so everything like we have is the environment. So the agent is the person or the robot or the algorithm which is acting. And so the the agent is the actor which is operating in the environment is the world, and the observation. So basically the only thing this agent has is the observation. So it has some sensors, maybe a you can say camera, a microphone, or some other sensor like ultrasonic sensor or other things. So whatever readings that are coming from the sensor, it has that observation. Like so basically observation is the agent's knowledge of the environment. Next, so basically based on that we create MDP or POMDP. MDP is when the environment is fully observable, and when it is not fully observable, we say that it is a partially observable MDP, right? So we'll see about this thing sometime later. So action is, so basically this agent is actually executing actions to perform some activity in the environment. Like whatever the agent needs to do, it like it do something, and that doing is done by some parameters, and that parameter is actually called an action. Like so parameter means like, so for example, if I'm talking about a vehicle, autonomous vehicle, right, it has to move forward, right, so using the throttle command, right? So this is throttle is the action. It has to steer, like going left or right, right? So this steering is the action, right? Going left, right, like how much left, how much right, right? So that activity is actually called action. So reward is like, so basically like whatever this agent is doing in the environment, right? If it is driving left or right, like so what reward or what incentive it will receive by these actions, it is called the reward, right? So basically the goal of the agent is actually to maximize the total expected reward, right? This is called as return, right? So it has to apply those actions which will give you the maximum reward, right? That's the main goal here. So we will actually see how is it that you can achieve this kind of goal, and you can train your robotic agents to actually come up with this thing. So basically the return can also be written in this mathematical form, where GT is called as return. And let's say the reward that you are receiving at current time is RST, 80, and the next state like you will receive is RST plus 1, 80 plus 1, and so on, right? So this is how you will receive this return. So basically we have multiplied the future returns by gamma so that we can discount it, and the reward is bounded, right? So that's the dimension. So this is just the explanation. Like we'll see these in detail sometime later. Like, so basically this can be written in a summation like this, right? So okay, now I will give you an example like how this reinforcement learning is actually coming up. So let's say we have an actor, like which is a robotic arm based system. Like so it has two arms, and the main task is, let's say, some assembly, right? So let's say maybe in an automation industry we are like doing assembly of an automobile, and this robotic arm is actually doing that. So it will do, what it will do is it will apply some actions, and we will observe like how good it is. Like so based on this how good it is, we will provide it some incentive. Okay, now your work is 3.5 only, right, not 5. So we will give that reward. And what is the change in the whatever the robotic arm did, whatever in the environment has changed, it will be observed by the actor, and then it will be returned to the actor, right? So the state and the reward will be returned. So basically agent lives in states, takes actions, gets rewards, and goal is to maximize its total reward. So that's the only thing in reinforcement learning. As simple as that. You don't have to think about more things, right? So okay, I have observed the environment. Okay, this is my state. I will apply some action. I will receive the reward. Okay, and I will try to repeat it multiple times, so that I will correct whatever I have done which was wrong, right? So that means I will do something repeatedly, hit and trial based, and I will try to learn which is the best thing out of it. Okay, so this is what reinforcement learning is. Okay, so just to actually say it in like very clear sense, let's say we have a robotic arm and it will do picking, right? So let's say it is not picking anything, it is going left and right, right? So we'll give it as a negative, right? Okay, I will give you the penalty, you are not doing the right thing. So that what it means. Okay, so it has only went down and picked the okay, that's the object. Okay, you are doing something right, right? So you are in the right direction. I will give you the small reward. But instead of picking it, instead of touching it, it will grab the object and it will pick it up. Okay, you are doing very good. I will give you the very high reward, right? So this what it means. So this is how the robotic arm is actually learning. Okay, so we'll see like what kind of algorithms we can have to actually train this robotic arm, where like we'll see how this kind of activity can be achieved. Like, so picking things up. Okay, so let me give you an example, like, so very simple example if you are not clear with it. So case one is like we take a cake and eat it. Like, so for example, like I will give you a cake. Okay, I have given you the cake. You eat it, and okay, you like it, and then like, so okay, you are done, right? You have eaten the cake. This is very simple thing. Second thing is, I will tell you how to make the cake. Like, so and then you will cook it, and then you will eat it. You did some work, right? So but I gave you all the information how to make the cake. Okay, so this is second case. Third thing is, I will just give you the taste of the cake. Okay, I will give you a small bite, taste it, and I won't tell you like what it is. So you will figure out all the things. Like, what will happen in third case is, the person will find out. Okay, so this should be will find out how to get the ingredients and how to make the cake. He will get the ingredients, he will learn how to make it, he will learn how to cook it, and then finally he will eat it. So that means we only know the goal, and we will do all the tasks, starting from identifying the ingredients, how to make it, how to cook it, right? So all the things. So this is what reinforcement learning is. The third case is reinforcement learning. We only know our goal, and all the things needs to be figured out by the agent. So that's what reinforcement learning is. Okay, so now I'll tell you a few examples, and then I will move to a few important things for reinforcement learning. Okay, so in success of reinforcement learning was actually shown in various fields. So for example, let me just put up everything in the slide. So one is the gameplay, right? You must have heard about deep Q learning, where like they were actually reporting results that on the Atari games, they have achieved human level performance, or maybe more than human level performance, in 2014's Nature paper. Then in 2016 and 2017, they have actually proposed AlphaGo and AlphaZero, where the DeepMind's like reinforcement learning based agent actually won over the international Go player, like, which was like, so he was unbeatable till now, but the reinforcement learning based agent actually won over him. Then in the control, for example, like, so for the helicopter control, like, how is it that we can actually make an autonomous vehicle, right? So that it can learn how to stabilize. Currently we have the pilot, right? It sees, okay, how to improve the jerk and other things, right? So we have the autopilot, it will handle it. It's just based on some situation, but like, how is it that we can actually train it, and so that, like, let's say for example, for military operations, it can go inside and do all the things that we want to do. Autonomous driving and drones, right? So we can't actually code everything for an autonomous vehicle, actually, because that person can come from any angle, and like whatever he will do, like, so we will not be able to preserve the collision. So basically prevent the collision. So we actually need to train, like, how to actually adapt to the different situations. That's what the goal is. Another thing is navigation, path planning, wind turbine. Look, there are many things that we can do in the control. Industrial automation, for example, financial portfolio management. Many banks have actually moved to reinforcement learning to come up with the buy-sell decision, to actually come up with strategies for hedging, for portfolio management. So these things are actually done by the reinforcement learning, where we can see how much loss or gain is seen by the customers for different things. So this is what like people are actually actually doing with reinforcement learning, right? Another thing is in neuroscience, mostly DeepMind is very famous for working on these things, where like how human memory supports reward-based learning is actually like modeled, how we do the representation learning, and etc., etc. Right? So if we can actually know how we see a table, right? So we actually don't know to learn, okay, this is a table, because we know, okay, visually it's a table or the chair like of like structure, right? So we have the representation and everything that is similar to it. We say that, okay, it's a table, it's a chair, whatever it is, right? If that kind of representation learning can be identified, can be modeled, then we can actually train a very good like robotic system. Right, so that's what the main goal is. Basically, in reinforcement learning, we are actually trying to come up with the with the algorithms which show human intelligence, right? So this which is the goal of AI. So I will tell you an example of Markov decision process, where Markov decision process is actually a set of these tuples where like we represent it by a set of states, set of actions, transition probability. Like, so for example, if you are in a state S and taking action A, then what is the probability that you will end up in the state S prime? Reward function for this particular configuration, and what is the starting state, discount factor, and horizon, right? So these things we actually define. So let me tell you an example with the example. Okay, so this is a cleaning robot. Like, so you must have heard about Zumba, right? Where, and even Xiaomi has actually launched a like a robotic vacuum cleaner where you just train it, like what your whole home structure is, and you just start it. It will automatically go to the different corners, and it will clean your home. Walking robot. So, for example, like, so this has fallen, right? It doesn't know how to stabilize itself. It has fallen. So basically we actually use these MDPs for coming up with them with a Markov decision process for this robot, so that we can train, okay, what actions it needs to take, right? So that it can stabilize its working pattern, so that it will not fall again. Another is server management, like for example, e-commerce website. Like, how is it, like we will handle the like millions of hits by the customers, like so that we use minimum resources and customers will not see any fault on the server side. So this is also where all of these things are coming into picture. Okay, so this is what it is. I think like my PPT was about 30 minutes, so I think I should skip this slide. So basically here I wanted to tell you like what is the state, action, reward, transition, GABA for this particular environment, where this is an agent, this is a porthole, this is a ball where you can't move. If you go here, you will die, and the goal is to actually pick this diamond, right? So you like, so this, take this as a homework, like how is it that you will come up with an MDP for this case, for this grid work. Okay, so this is an homework for you. Okay, so now this is an MDP, right? So you actually have a model, right? You have the state, you have the transition probabilities, you know what is the reward, right? So these things you know. Okay, and you can actually you can train it, like come up with a policy to which maximizes the reward. But in reinforcement learning, we don't know how the world works. We don't know this MDP. We don't know what is the probability of going to the next state. We don't know anything. We just perform actions in the world to find out like which is best, and like we collect the rewards, and by based on that we come up with the right strategy for doing something, right? So this is what reinforcement learning is. So for example, if I give you an example, this is a breakout game where like a deep RL based agent is actually learning how to like break all these bricks by this ball, and whenever it is coming down, like, so it should come like near to it, so that it will bounce back. Okay, if it will go down, it like the game will over, right? So this is entirely trained by a deep q learning based agent. Okay, another is autonomous driving using PPO. PPO is another RL based algorithm, where just see, right? So it is learning how to drive on the different terrains, and it actually successfully learns how to drive after a few iterations. Okay, so another examples are like robotic environment in simulation. For example, like this I have shown you earlier as well. Like, so picking objects. Like using the robotic arm, and like picking these and placing it somewhere else. that means like table clearing kind of objective, and this is how it actually works in simulation. Basically, a camera is installed in near the gripper, and you can see the top view, right? So this is what the robot is actually seeing, and you have to train how to actually pick this particular object. So there are other kind of input as well. For example, segmentation mask is there. Okay, this should be a depth map, but like it is not clearly visible. But this is how the robotic arms are actually coming, and like, so whatever data you are receiving from the sensor of this robotic arm, you need to train it so that it can learn how to pick and clear the table. So these are a few things, right? So types of RL algorithms that we have is like, so these are basically categorized into two parts: model free RL algorithms and model based RL algorithms. And like, so basically model based is very typical or difficult, you can say, where like, so we actually need to have the model of the world, which is not entirely possible on all the cases. And like, if we know the model, we can have the various algorithms. For example, DynaQ is also one example, and AlphaGo is Alpha Zero is another example. So we will mostly talk about model free algorithm, where we actually don't know anything about the environment and we have to go with it. Okay, so these are policy optimization based and Q learning based, basically value based and policy based methods, where like, so the methods could be both, like, so for example, both policy based and like value based, which are like commonly example of factor critique methods. Like, so this is how these are actually categorized. The policy gradient is purely policy optimization. A to C is both, like, so actor and critic, both value based and policy based. And similarly, PPO and DDPG, TD3, like all are actor critic based methods. DQN, C31, these are value based. I will tell you maybe in the coming presentation, where like, how is it that you can train DQN or TD3 or SEC based algorithms, right? So this is how the structure of RL algorithms is, and we will mostly use SEC, TD3 and PPO for training our robotic arms, because these are continuous sections, and these like DQN is mostly used for what we say, this discrete action space. Okay, so now what I want to tell you about, like, the last part, I will finish it in a few minutes. So basically, if you want to learn about like how to train these robotic arms, like, so for example, let's say, so this is what we have trained, like for the robotic arm. So using using policy gradient, natural policy gradients, and this is what we are actually coming up. So this, the robotic arm is actually going to the door. It is opening the latch and then open the door, right? So this is how you actually train it. And if you want to know how to train it, how to learn it, so there is a training program, like you can register for it, which is available on this link. And see, right, so also, like, if you want to learn how to pick objects from a table, and like, so how is it that you will be doing that? Both of these applications will be covered in this training program, and all the details can be accessed from this registration link. So if you have any queries, you can email or contact us on the phone number, and all the details will be mentioned here. So details about the training program is basically, so we will cover all the fundamentals of deep learning and machine learning. We will cover like various RL based algorithms. So we'll tell you how is it that you can like train a robotic arm in simulation. Like, for example, we have two like application: door opening by a robotic arm, and robotic arm for picking application. So basically, placing we'll see, like, if we will cover, but we'll cover only pick. Machine learning interview preparation will also be included, and industry specific projects are there. So for example, you can pick one project and you can actually complete that like in the guidance of our mentors. So it will have all live lectures. The faculty is expert from the field, and you can check the link where by which you can see like who are the faculties. One-on-one assignment evaluation will be there, and like, so we'll give you extension for completing a project. It will be totally free of cost, based on your performance, and it also includes coming up with a research paper or guiding you for a startup, right? So we'll give you, basically this extension will be in terms of 3-month performance based internship. So there are a few paid internships as well. So basically these will be offered based on your performance, and basically like based on the performance you will also get a direct opportunity to be a part of our Super 10 program. So this is what we can do. And if you want to register for this training program, you can go to this link and register for it. Okay, so thank you for like this thing. So for attending this lecture. If you guys have any queries, please put it in the chat box. I will now answer your queries, and if there are many queries, we will have another lecture where like we'll try to show you like how is it that you can actually train it. And if you are interested in learning about these algorithms in detail, just check about this registration link. Like go to this link, register for it. It will be a 6-week training program, and like if you are a student, you will get 30% discount over the registration fees. So basically, let me go to the questions. So Dev Manchanda has a question, sir. What is the difference between AI and ML engineer? Okay, so basically so basically these are highly like interrelated things. So AI and ML engineer, basically like currently the job postings that are coming, like so they have the same requirement. Basically machine learning is totally like having those algorithms which are learning from the data. AI is more general in that. Like so, for example, it contains all the machine learning algorithms, but it also contains like algorithms like, so for example, evolutionary algorithms are also part of AI. The other planning based algorithms, control based algorithms, for example, if you say, right, A star planning cells, that is also a part of AI, but that's not part of ML. So in AI, if I talk about, like, so they are actually asking you for more general thing, and in machine learning they are actually asking you for like for specific things which are actually trained using what we say, using data only. Okay, so the next question is from Dev Manchanda, where he is actually asking, sir, what is the difference between AI and ML engineer and data science engineer? Okay, data science engineer is also like working on like, so basically data science is another subfield. Like so basically it also has some relations with that with the machine learning, but here we are working on more statistical based approaches. Okay. Sir, we give reward to the machine or to the programmer. So basically the reward is given to the machine which is learning. So for example, let's say your agent is learning to grab the door, right? So if it grabs it correctly, it will receive the reward, and so that it will know that, okay, this is the right action. You will give it the penalty so that you will know that, okay, it's the bad. Okay, and like so we'll tell you actually how this reward thing is actually going into the program, and how is it that you can train the algorithms for it. Okay. Okay, so next question is, what is the difference between machine learning and deep learning and reinforcement learning? Okay, so machine learning is everything, contains all the algorithm which learn from the data, and deep learning is a part of machine learning where you are using neural networks for achieving this training goal. And reinforcement learning is another learning strategy in machine learning where you are learning with the interactions from the environment. Okay. Okay, so next question is, how RL is used in online advertisement? Okay, so Dev, I think this is a very specific question. Like you can get in touch with us on this mobile number. You can WhatsApp us, and we'll actually try to answer your queries. So basically, like, let me just tell you some information about like how it can be used for online advertisement. So for example, let me pick a specific case of Amazon where you have you already have a profile, you have some search history, you have some purchase history. Based on your interest, and like what they actually do is they actually try to identify similar people, right? And they will see like what they have purchased. So whatever they have purchased, they will actually try to show you that those objects. Okay, so this is how actually this thing is working. This is mostly collaborative filtering based work, but how they use reinforcement learning in this is like basically whatever they are showing you, and if you click on it, they get the better reward, and their algorithm actually learn from it. Okay, Srinivasan Raghavan says that like, it's a very nice session. Thank you for the comment, Srinivasan. And so what is the prerequisite for the training program? Dave is asking. So basically, the only prerequisite is that you should know the programming. Okay, and if you know Python programming, it will be very good. If you don't know Python, like we can send you a few learning resources by which you can learn how to how you can learn the Python programming. So the only prerequisite uh, is programming. Okay, Srinivasan is asking, can you highlight areas of finance and HR in AI? Okay, in finance, many banks are using RL. Uh, so you are asking about AI, right? So AI has more general sense. Let me tell you about finance for RL. Like so for example, like buying and selling decision of anything, like whether it's a house, whether it's a stock price or something crypto or something else, right? So basically, like this buy sell decision can be captured from the history of like of that particular like asset, and so you can actually train like based on the events that are occurring and see whether like buying or selling at this particular time is giving you better reward or the poor reward, right? HR, like I will tell you about more general AI. So for example, for HR, right, so one of the most tedious tasks is to shortlist resumes, right? So what researchers are doing is they are actually using natural language processing to parse the resumes and identify whether this particular resume is a good fit for your company or not, right? Whether they are from the top institutions or not. So this is the thing which is actually done automated like for our HR. Okay, so these are the two cases that I can give. Okay, so Dev is asking, will you teach AI and ML from the basics? Yes, Dev, we will teach AI. Yes, we will teach AI and ML from basics. We will also tell you about. We will also cover basics of programming. We will also, let me write it. Cover basics of programming at a faster pace. We will start. The only prerequisite is this programmer. Okay, so these are the two things that like I could say. Like, so if there are more queries, please feel free to write in the chat box so that I can answer it. And if you want to learn about the algorithm, please feel free to register for our summer training program, and like based on that, like you will learn about these algorithms, and you will see how is it that you can train your own robotic hand for door opening and for picking objects from a table, right? So if there are more queries, please feel free to ask in the chat box. I will try to answer this. So Dev, I hope I have answered your all the questions, and Srinivasan as well. So thank you for your queries. If there are more queries, please feel free to ask. And Dev, like we will start from like the basics of machine learning, and we'll also tell you. So basically, this will be totally practical. We'll tell you how to train it. We'll also show you the code and other things. Okay. So basically, we will tell you like how is it that you can write the code for a particular algorithm, and we will also give you 4 assignments by which you can improve your learning and see how you can actually write things on your own. Okay, so Devi is asking another question, sir. We will learn about neural networks, or will this course be specific towards robotic arm? So basically, Dev, we will start from machine learning, where we will tell you about supervised learning and unsupervised learning, and then we will start with the deep learning, where we will tell you about neural networks, convolution neural networks, RNNs, and then we will. So basically, this is for 3 weeks. Sorry, this is for 6 weeks. For 3 weeks, we will focus on machine learning and deep learning, and in the last 3 weeks, we will focus on reinforcement learning, and there are other applications as well. For example, two applications are robotic arm training for door opening and picking objects, and another application is actually in the deep learning side, where we will tell you about how is it that you can actually recognize objects in the real world, right? So basically, it will cover all the neural network based stuff. I hope I have answered your question, Dave. Is there any other question? Okay, I hope there are no more queries. So if you have any queries, please feel free to contact us on on this email ID and phone number, and based on that, we will actually reply to your queries. You can also contact us on WhatsApp on this number. You can email us, and if you are interested in our summer training program, you can register on this link. Okay, thank you for attending this session. We are ending the live now. Thank you. Okay, Dev is asking, like, will this be on campus? Hi Dev, we have a MOU with MSIT. Please ask this question on WhatsApp, and we'll answer it. Right. Okay. Thank you everyone for being here, and okay. So if you have any queries, please contact us on this email ID and or on WhatsApp or on call. Right. We'll try to answer your queries, and thank you for attending the session once again. Okay, we are ending the broadcast. If there are any queries, contact us on email. We'll not be available on the chat after this time. Okay. Thank you. Dave, you can contact us on the phone or on the WhatsApp or on the email. We'll answer this thing. Thank you. Bye bye.